In this lecture, we are going to discuss about remark on Laurent's theorem. Recall the statement of the Laurent theorem. That is, let Fz be analytic in the ring shape region, ring shape region D, bounded by two concentric circles, circles C1 and C2 with center Z0 and radii R1 and R2 less than R1. Let Z be any point inside D, Z be any point in D, then Fz can be expressed by an infinite series of the form this 0 to x. Fz can be represented by infinite series of this form equal to 1 to the power infinity bn z minus z0 to the power minus n. Here these are the negative powers of z minus z0 and these are positive power of z minus z0. This is known as analytic part. This part is known as analytic part of Laurent's theorem, and this part is known as principal part. Principal part. Where an is my 1 by 2 pi I integral of a c1 f of w dw w minus z naught to the power n plus 1, and bn is given by 1 by 2 pi I integral of a c2 f of w minus z naught to the power n minus 1 fw dw, where n lies from 1 to 3 up to infinity. If C is the circle with center z0 and radius r such that r2 less than r1, and the integrand is analytic in the region R2 mode of z minus w minus z naught R1, then we have bn is this one 1 by 2 pi I. Now our integral is over c f of then we have this one w minus z naught to the power n minus 1. This is n minus 1 fw dw. Okay, if I bring this to denominator, it will be of this form 2 pi I integral of c f of w dw by w minus z naught to the power minus n plus 1. When I will bring this to denominator, the power become negative, and it will be equal to my a to the power minus suffix minus n, because a n is my, since n is 1 by 2 pi I. Now when I consider the region to be of C, then here again integral will be over C. Fw dw w minus z naught. Now this is n plus 1. Bracket close. When it is n, we have an. When it is minus n, we will be, we have we have it a suffix minus n. So bn is equal to a minus n. In that case, our Laurent series this becomes, now if I put a n equal to a n equal to b, bn equal to a minus n, not a n. Here if I put bn in place of bn a to the power minus n, then it will be, all the n will become negative. So this series will become, now, right, in that case, in that case in that case resulting resulting series become resulting series become fz equal to sum over n ranges from minus infinity to plus infinity a n z minus z naught to the power n naught minus n, it is n. Okay, where a n is given by 1 by 2 by I integral over c f of w dw w minus z naught to the power n plus 1. So if since the circle with center z naught and radius r such that r lies between r2 and r1, and integrand is analytic in this region, then our Laurent series expansion is given by this formula. Okay, with that I would like to conclude. Remaining will be in the next lecture. Thank you.